Okay, so we're doing Unit 5, which is trigonometry. Trigonometry is basically we're talking about, for the most part, right angle triangles. So we have this. This is our nice little right angle triangle. So we're talking about there's certain ratios and proportions that exist with a right angle triangle. And this is what we're going to be talking about. We're going to talk about using trig ratios as well as the Pythagorean Theorem to help us find missing measures in a triangle. But first, we're going to do some triangle basics, okay? So we're just going to review some rules for labeling, particularly how we would label things with regard that's going to help us use our trig ratios and our Pythagorean theorem. Now, there are, when we're talking about labeling a triangle, there's three ways to label a right triangle. Three ways. One is Pythagorean labeling, one is relative labeling, and one is vertex labeling. So let's start by talking about Pythagorean labeling. In any right angle triangle, there's always one side that's longer than the other two. And this side is always across, directly across from the right angle. Okay, so if you have the right angle, you draw a line, ignoring the other two legs on either side, that is the longest side. And we call this side the hypotenuse. Okay, so it's always labeled the hypotenuse, and the others we can refer to as just legs of the triangle or sides of the triangle. We're going to talk a bit about how we label them. When we're using the Pythagorean theorem, one leg is A, one is B, and the hypotenuse is always C. Okay, and that's how the Pythagorean theorem will work. And it doesn't matter which of the two legs are A and which is B. You can switch, they are interchangeable. Now, relative labeling, which is going to really come into play when we're using our trig ratios. We always start with a reference angle, okay? So we have to think about where we're looking from. The reference angle is either the angle you're given or the angle that you're finding. And with regards to that angle, we can label the legs as opposite and adjacent relative to that reference angle. Opposite means it's across the triangle from the reference angle, and adjacent means it's next to the reference angle. So if our reference angle is right here, now our hypotenuse is always across from the right angle, right? It's always going to be that one. But the opposite, if we look from our reference angle, is going to be across the triangle from that reference angle, and the adjacent is going to be right next to it. I often do a little hook, but that will do. Okay, so now that's if the top angle is our reference angle, this angle up here. If, however, we're looking from the other angle for our reference angle, things switch up. Now, look, the hypotenuse is always the same. However, if we're looking from this other angle, then the opposite angle becomes this, or the opposite side becomes this side, and the adjacent side becomes this side. Okay, so I always like to draw all over my triangles, and I will circle my reference angle just so that we can find it. But you need to know these because all of our ratios depend on those relationships and which side is which. Okay. Note this little term here, this, I'm going to call that theta, because that's what it's called. It's a Greek letter, but we often use it to talk about our angles. Okay, as particularly if we don't know what the angle is. Okay, and when we talk about a reference angle, sometimes we might also call it RA for reference angle, just so that you know what I'm talking about. Okay, so Pythagorean theorem. We're going to spend a bit of time on Pythagorean theorem because it is so fundamental. Pythagorean theorem, you use this until you're old and gray, trust me. Now, but the Pythagoreans were Greek mathematicians. It's actually Pythagoras himself was a Greek mathematician. And he discovered a relationship between the parts of a right angle triangle, the sides in particular. And what he noticed is with the legs and hypotenuse labeled, he could make a square from each of those angles, or those sides, right? And the relationship was discovered that if the angle indicated was 90 degrees, if he added the other two together, they equaled the larger area. So now with a square, the area of a square the formula is side squared, right? So for each leg, the area was the leg squared. So if you called this A and this B and this C, as I talked about earlier, what he found is A squared plus B squared equals C squared. A being the area of that smaller square. Sorry, A squared being the area of that smaller square, and B squared being the area of the second one, and then C squared being the area formed by the hypotenuse. Now, there are three things you can use the Pythagorean theorem for. Testing an angle to see if the angle is a 90-degree angle. Finding the measure of the hypotenuse given the two legs. And then finding the measure of one of the legs given the hypotenuse and one leg. We'll use these most of the time, but we also will do this where we will test to see, does that ratio hold true? And can we use the hypotenuse to do this? Now, to test an angle, you're going to need three sides. Okay, for the other two, you only need two to find the third. Okay, so, and we'll do some practice with those to kind of see exactly what's going on with that. Now, another relationship that we know about triangles, and this is any triangle, is that the interior angles always add up to, oops, I don't want that pen, I want this pen. The interior angles of a triangle always add up to 180 degrees. So what that means is that if I take all three of those angles and add them up, they're going to add up to 180. So 60 plus 60 plus 60 equals 180. 90 plus 60 plus 30 equals 180. 30 plus 130 plus 20 equals 180. So what you can see for that is that if you're missing one of those angles, but you have two of them, you can use the two you know and the fact that they have to add up to 180 to find the missing angle. I am sorry. Testing an angle. So let's do some examples just so we see what we're talking about with all this stuff. Prove whether or not the following are right triangles. So we want to test to see, are these right triangles? So the first thing we have to do is we have to find our hypotenuse. If this is a right triangle, the longest side is our hypotenuse, so it would be 13. So we'll label it C. We can label either of the other two triangles A and B, doesn't matter which way. And now what we're going to do, we're going to test it using a left side, right side comparison. On the left side, we have a squared plus b squared. And on the right side, we have c squared. So we're just going to substitute in 5 squared plus 12 squared and 13 squared. And if this works, they should be equal. So we'll get 25 plus 144 on this side, and 13 squared is 169. When I add 25 and 144, I get 169, which does indeed equal 169. So check. Yes, it is a right angle. So this is a right angle because the relationship works. Let's check the other one. Remember, we're saying that the hypotenuse is always the longest side. So what we're checking to see is if that's a right angle. So this would be C, this would be A, and this would be B. We're going to set up a left side and a right side, and we're going to put that in. So this would be A squared plus B squared is equal to C squared. So 9 squared plus 10 squared equals 15 squared. We hope so. So this would be 81 plus 100. And 15 squared is, oh, where did I go? 225. So no, this does not work. It's not a right angle triangle. Okay, so that we've tested, we've compared those ratios to see how it works. Now, another thing that we can do is we can, solve for the hypotenuse. Okay, so we're going to take our Pythagorean theorem and we're going to use it to solve for the hypotenuse. So we have to do some rearranging. But let's fill this in. So we're going to find, we're looking for x. So x will be our c. Sorry. Boop, 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 boop. Then this can be a and this can be b. All right. So we're looking for c squared. So we know a squared plus b squared equals c squared. Well, a is 12.5 squared plus b is 10 squared. And equal to x squared. We're looking for x, right? So we get 12.5 squared is 156.25. 100 squared, or 10 squared is 100, and that will equal x squared. We add this up, we get 256.25 equals x squared. So now what we want to do, we want to find what x is. So what we have to do is take the square root of both sides. So we will get x is equal to the square root of 256.65 is approximately 16. There might be some decimals there, but it's pretty close. 256.25, take the square root. Yeah, it's 16.0078, so that's close enough to 16, okay? So now we've discovered that missing side, and that's our hypotenuse, okay? Now we can also solve for a leg, so one of the other sides. Here we found the hypotenuse. We were looking for our hypotenuse here, right? And here we're looking for one of our legs. Okay, so we use the same formula. We're just going to have to do some rearranging. So let's label. This would be, I keep doing that with the wrong pen. This would be C. And we can make this A and this B. It doesn't really matter which is which. A squared plus B squared equals C squared. So let's fill in what we know. A is 5 squared. B is x, and C is 15 squared. So when we calculate this, we're going to go into solving equations mode. 25 plus x squared equals 15 squared is 225. Now, when we're solving equations, we want to move this over, so we're going to move over the 25 just like we did in our equations. That will cancel out on this side. And we'll get x squared is equal to, well, what's 225 minus 25? It's 200. Now, we've got an x squared equals 200, so we're going to have to take the square root of both sides. And we'll get x is equal to, it works out to about 14.1. And we can write a little approximation sign. Okay? So that would be our answer for side B. Okay? Depends too. Look for rules on rounding to determine what decimal place. Okay? Now let's do a little practice labeling our sides and angles. We generally speaking label across a triangle. Okay? So what that means, when we're labeling sides and angles, the angles are capital letters and the sides are lowercase. So we match them up across. So if that angle here is R, then this side is R. Similarly, if that angle is P, this is P, but it's a lowercase. And if this side is Q, then this angle is Q, and it's an uppercase. Okay, so as I said, angles, uppercase, and you're always looking opposite the side, right? And sides, well, I don't know what word that is. Sides are lowercase, and they're opposite the angle. Okay? So you match up the letters by looking across. Okay? And that's just to name, so now I know that this would be a triangle PQR. Generally speaking, we say it's alphabetical. Okay? Labeling the sides in relation to a given angle. So this was, remember I talked about there was a third type of angle? This is vertex labeling. So if I want to tell what is the name of that triangle, that's what that would be. Here, we're going to do some relative labeling. So that's where we're putting in, we've got our three sides, opposite, adjacent, and hypotenuse. And I'm just going to use OPP, ADJ, and hype. So this is for opposite. This is for adjacent. And this is for hypotenuse. Okay? So, looking at this, theta is our reference angle, right? So that's what we're looking from. Now, always across from the right angle is our hypotenuse. And if we're looking here, across from our reference angle is our opposite. And attached to our reference angle is our adjacent. So that would be our relative labeling. So you're going to do some of both of those, depending on what they ask you for. And we're going to get some practice in, and then we're going to check back in and see how we're doing. You're going to also use the Pythagorean Theorem to solve for sides, and you're going to use that interior angle rule. Okay, so you've got some practice ahead of you.